Yay. Okay, so we're talking about the project, those of you that just got here. I talked about this in the morning. I forgot to start recording. So those of you watching the videos, check the morning's recording for the first part of this discussion. We didn't talk about much. You didn't really miss much. So we're getting the random level of significance. We opened this link that opens this column of data, and we're going to data and sample. We select the level of significance to tell StatCrunch, here's the data set. You select, you need two alphas, so you could just do two samples here and get both of them at once. And then do your compute. And here's your two levels, your two alphas. So for me, that would be my alpha for number 4. And then again for number 10. And then all the rest is just do 2 hypothesis tests. One for the Skittles, one for the M&Ms. Does that seem doable, y'all?
Mm-hmm.
Okay, good. Any questions, anything we're concerned about?
I struggle with number 6 about probably making a type A error in the hypothesis test above.
Yeah, everyone struggles with that one because you're thinking it needs to be more than what it is. I think if you go to page 231, you're told that alpha is the probability of a type 1 error. So I just randomly generated 2 probabilities of making a type 1 error. Here's one, here's the other. So your answer for that is literally alpha equals whatever you randomly generated.
Whatever I picked.
Whatever you got.
Okay.
What's your explanation? Well, the probability of a type 1 error is equal to alpha. That's the explanation. Yeah, that's it. It always gets people. And then remember that the type 2 is beta. And we don't calculate that one. Let's see, that's what our thing says here. We don't calculate it, but we do know it's related to alpha. Cool, good question. Let's just glance at the chapter 11 project. It is not due until next Sunday.
Can you go back a second? I had a question on number 12.
Definitely. 9, 10, 11, 12.
So that's pretty much just like if you decrease alpha, you increase beta?
Nailed it. Yep.
Okay.
That's the relationship between the two. Yep. And vice versa.
I was thinking it needed to be harder than it was.
They all feel that way, right? We've been doing all this complicated stuff, and then yeah, good. Okay, cool. So the chapter 11 project is found on day 28. So that's Thursday's day. And similar thing. This time we have to randomly generate a confidence level for our confidence interval. You're going to do that once. So it's a different column of values. They're all larger, right? Notice they're 70 to 99, whereas these alphas are 0.01 up to 0.15. Which should make sense to you, right? Because remember, C levels are the higher percentages, and the alphas are the smaller ones. And the one minus each of them gets the other. So you're doing that. There's another equations file. You don't need to re-click it if you've already downloaded the one. But there are a few things that get people with Chapter 11 project, and that's usually this first page. Now, first, if you download the Word document, this table gets screwed up for some reason. At least it does on mine. So I'll show you what happens. I'm doing File, Download, Word document. And maybe it won't screw up on your all's Word documents. I don't know. We'll see what happens. Yeah, so like it makes this table super monster. Oh, there, I just fixed it. So you see how I could see this corner over here. I just drug it in so you could write it. And really all that matters is this difference. So what you're going to do is you're going to take 4 of the colors from your 2 bags, just these 4 colors. I think they're the only ones they share. I could be wrong. But note you're going to use your sample sizes, so the entire bag, even though we're only talking about 4 of the 8 colors or however many are in the bag. And we want you to write down the X's for each of the colors, and then the P hats for each of the colors. So remember, total M&Ms, total Skittles for the whole bag, and then green divided by that number. And then for whatever reason, we're asking you to copy these proportions here, and then copy these proportions here. And then you're going to calculate the difference between those 2 proportions. In this order, M&M proportion minus Skittle proportion, and you're going to get these differences. Y'all feel okay about that? Like, let's pretend this was 0.13 and this is 0.06. And so we're going to do 0.13 and 0.06, and we're going to subtract, and we're going to get 0.07. And then let's do 0.07 and 0.19. Oops, I put it in the wrong spot. 0.19. So down here, 0.07 minus 0.19. And that's equal to, I don't know, negative 0.12. So you'll have all these, and then you're picking the largest difference, but you're ignoring the negatives. You're doing the absolute value. So between these 2 numbers, the orange difference is the largest. So that would be the number 1, and the second largest would be the number 2. How are we doing? And you're going to use each of these differences once to do a confidence interval. So the second largest, whatever answer you did for number 3, you're going to do a confidence interval with. And for whatever you picked for number 3, which was the largest, you're going to do a hypothesis test with. And this is all section 11.1, exclusively 11.1 stuff. All right, questions, comments? Last projects, yay. All right. For the 1.6 notes, is it all of the pages you want? I have no idea what you're talking about, Will. That's a really good question. None of the pages? What you need from 1.6, is there like a thing in here that says submit 1.6 notes? Maybe that's what it is. What you need to know from 1.6 is 2 groups measured once, 1 group measured twice.
I thought I removed that.
It's still on mine.
It might be in the other class then, Eric.
I know that I saw it on the right side column when you look at stuff that needs to be done. But I
Oh,
don't
I might forgot to delete it from the
Yeah.
assignments then.
Because
Oh, I hate how,
it's not here, but it's on the right side.
We'll get rid of that. Don't worry about that.
yeah, you guys don't need to do it.
No. Hooray.
You
Yeah, it's even in the
overachievers.
app.
Do that. Gone. Okay, good. So as long as you know that when you're looking at 2 samples, that if you have 2 groups that you measure once and compare the 2 groups, that's independent sampling. And if you have 1 group that you measure a pre-value and then a post-value or a comparative value, you're good to go. There it is. Okay, done. Thank you, Will, for that catch. Yes, overachievers. All right, so let's test that. 11.2, number 2, we got 4 questions. This is page 724. You just need to decide whether A, B, C, and D are independent samples or dependent samples. So I'll give you like 3 minutes to think through it. Put a timer for 3 minutes. So looks like my timer stopped. How did we do? Nope, here it goes. 2, 1. Blood pressure levels before and after massage for 45 patients.
Dependent.
Nice. That's a classic example of dependent. We measure before and after. So you're measuring the same person, comparing your beginning value to your ending value. Okay, University of Michigan versus Michigan State.
Independent.
What? They're the same school, right? Whoa. That's blue and green, right? There's difference. Okay. All right. One team is undefeated. The other team beats up the other team, right? I don't know. This is a tricky one. Identical twin pairs, 66 of them.
Dependent.
Yeah. This one is a classic, like the first person you pick determines who the second person you pick. So twins, we talked this morning that it doesn't have to be identical. It could be fraternal, I was taught. It could be like dating pairs or like romantic pairs, and you pick the first person and that determines the second. Siblings, any kind of the first person picked determines the second, which is a different scenario than this one, right? Where it's the same person, you measure them before and then you measure them after. Here, it's still one group measured twice. It's just that what you're comparing is different individuals, but they are connected somehow. And the last one, second of two different drug therapies on two different groups of, I mean, two groups measured once, right? Independent. Okay, so note we're working on means, which means we're going to have a quantitative data set. This is a dead giveaway that you're working with a dependent sampling. Dead giveaway, especially when you see this difference row. Like you don't even have to think, you just see this and you're like, oh, we're doing dependent sampling of means. I can contrast that with what you're about to do tomorrow in 11.3, where you have independent samples. Look at those two samples. They're clearly separate boxes, and we have sample A and sample B, and we're not matching up the numbers. I think we even have different amounts of values in the two boxes. You could have the same amount, you could have different, it just depends on what happened. This is independent sampling for two means. So that's one of the, like, if you're given a table of values, if you're given a data set, you know, number one, you're working with a mean. And then number two, if the tables are disconnected and the two separate samples, it's independent sampling, two groups measured once. If it's one table that's smashed together and you're calculating a difference and there's the exact same amount of samples values in each sample, you know it's dependent sampling. Okay, I think maybe you know how to do this. Smash the pre and the post in StatCrunch, let it calculate the differences. The thing that I want to make sure you know is, what question are you answering in B? Remember, we have 4 types: verify the requirements, construct a confidence interval, calculate a sample size, the how many or estimate, or perform a test. Which of the 4 are we doing?
Constructing a confidence interval.
Nice. Construct the confidence interval, so our answer should look like this. How much time do you think you need? 5 minutes?
Sure.
We'll start there, and if you get done early, tell me, and we'll talk sooner.
So the pre-test goes in its own category and then the post goes in its own?
Yeah, because we're going to let StatCrunch do this subtraction.
Okay.
Pre minus post. You could do it yourself in your head if you wanted to. But you have to enter it in StatCrunch at some point anyway, so why not let StatCrunch do all the work? Did I answer your question?
Yes.
I may not have. Shall we chat? Did we feel good? This says state the StatCrunch path used and the result. I'm not super worried about the path. This is 278. Hey, that's good. Nope, it's not 278. If you want to know the path used, of course, you could check the confidence intervals for matched pairs differences, and here's your path. This is what that's referring to. Our answer is this. Do we all have the same answer? We're looking at negative 4.6, was it say 3 decimals? 88, comma, 1.288. Before we go anywhere else, what special number is within the interval?
0.
Good, right? So that means that there is no difference between the scores these businessmen got before they took the test and after they got the test. Now, if you think about what we're expecting to happen, we're expecting these numbers to be the bigger ones because they took a class that should help them perform better on the test. And these numbers should be the smaller ones. And so if we do the subtraction, we should get a negative number. In other words, this should be less than 0. If you look at the mean we got, yikes, I guess I did start that. It was less than 0. It's just that it wasn't, it's not significant, right? Because 0 is in the middle. So that means it's not reasonable to believe there's a significant difference in their knowledge of tax law. Like the class was a waste or the exam doesn't really measure anything. So it's no, because 0 is contained in the interval. By the way, if this is the multiple choice options, these two are never correct. I guess we could phrase the question differently to make yes the correct answer and no the correct answer, but that would just be mean. What do y'all think? Does that seem okay? Oh, I didn't write these down. You're supposed to write these down as well. The 2 and the -5 and all that stuff, but yeah, whatever. Okay. How about we do the hard one? Can you read the output? The first thing I want you to tell me is what test has been done based on what you see in the output here. Is this a hypothesis test or a confidence interval?
Confidence interval. Mhm.
How do we know?
Because it says paired T confidence interval.
Good. Okay.
That's
Like,
what I said.
you're like, come on, guy. Like, it's right there. But seriously, people don't take the time to read it. I mean, I'm just highlighting that it's there. Just read it. Okay. So go nuts. See what you can do. That's essentially what you're doing here. Basically, all the information you need is on the page. We're just testing, do you know the symbols based on the readout? This problem ends really on question E. I mean, these are related, but not really. So you're going to use this for the next 2 pages, but I'll check back in like 5 minutes and see if you've got A and B done. Set a timer for 5 minutes. I need a sweater. I'll be right back. Oh, I forgot to start a timer. How y'all feeling? You got A done?
Mhm.
So like copy and paste, degrees of freedom, 23. Do we all have memorized degrees of freedom is equal to n minus 1,
Right.
thus degrees of freedom plus 1 is n. D bar is a tricky one, right? So D bar is really X bar. They're the same thing.
Mhm.
But what the reason we put D bar is because what we've done is we've subtracted all these paired values from these two different measurements and taken a 2 sample and turned it into a 1 sample. But that 1 sample is comprised of a set of differences. We then calculate the mean of all those differences, hence D bar. So it's just the mean, it's just the point estimate. And then do we all remember the standard error is the standard error? These two are the same. Is that okay? Now, B is a little strange because we've talked about this as like 2 samples or dependent sampling. But really, if you think about what's happened is we've really just grabbed one group of people. In this particular thing, it's a group of business managers, and we've just collected data from them twice, and we're comparing the 2 collections. So we don't really have 2 different populations, and we don't really have 2 different samples. It's really just 1 sample that we've done 2 measurements on that we're comparing. So when we go through our requirements, we don't have to count for 7 things. We just have to do 4. That is, the sampling we did pre and post was random. The sampling we did was matched pairs. It's 2 groups measured once. Wrong again. 1 group measured twice. That sample is independent of the population we drew it from, right? Our population didn't change when we drew the first sample to when we collected the second sample. It's just business managers taking this class and we pulled them out and calculated, did a sample. So we just need to do 1 of these. And then the normal is, again, just one check. And in this case, we've got the graph. So we're saying the normal probability plot is approximately linear. Does anyone need me to write any of these down? Does everyone have them? Okay, cool. How did we do on this page? Or should I pause and let you contemplate? Again, the information you need for this is up above. Do you need some time?
Mhm.
Let me give you 3 minutes. Set a timer for 3 minutes. All right, how'd we do? Y'all remember that the lower limit and the upper limit are the pieces of the confidence interval, right? So when we say confidence interval, what we're asking for are this. So it was 13 point something and 25 point something. Confidence level was always a little tricky, but are you all good at that? I mean, we read it at the beginning. No, we didn't.
It's right there. Yeah.
Yeah, it always said percentage confidence interval, which could trick people. So that would make that 90%. We needed these two things to more or less like solve for the other two. So do we know the level of significance?
0.1.
Nice. Or 10%, either one. Good. How about the margin of error?
It's the upper limit minus the lower limit divided by 2.
Nice. If you add the upper and lower limit, you'll get the D bar, or the point estimate. Good. What was that? 19 point something? 19.5 something something? Dot, dot, dot.
542.
542. Okay. Thank you. I got lazy. I didn't want to type it. How'd y'all do about finding the critical T value? Did you remember StatCrunch? Did you remember that on page 271, there's like the reference sheet of how to find the critical T value? So you're going to stat, calculators, T calculator, between, degrees of freedom of 23.9, compute, oh, it's plus or minus 7139.
Actually, Eric, that margin of error is 5 point something.
Thank you.
5.8795.
5.
That
Oh.
19.542 was from the previous page. We're kind
I
of
was so confused because I sure wasn't getting anywhere near that.
yeah.
Oops, that was the D bar. I clearly was remembering it wrong from this morning. 5 point.
8795. 8795.
Nice. Cool. Okay.
Are you guys
That-
taking a deep breath right now?
Woo!
Freaking me out, man.
Now that's what I get for not typing things in, right? Okay. Good. Everyone. Oh, and then the graphing, like technically, or the drawing is technically supposed to be this, but if you drew the between area, that's not really wrong either. We're happy either way. Is 0 in the confidence interval? Is 0 larger than 13?
No, it's not in there.
So 0 is over here. It's got a ways to go to get to 13. So it's not in the interval. So is there a difference in the cholesterol? If we read what this context was, we got these Michigan hospital employees who had been eating a standard American diet, which apparently is not vegetarian. I don't know. And then they had to eat a vegetarian diet for a month. And then they checked their HDL levels before and after, or their cholesterol levels before and after. And we found that there was a, what is this, a decrease or increase? Before minus after, and we've got a positive mean. So it decreased. Because when they subtracted, they got a positive number. So it means the big number was first and the small number was second for that to end up being a positive number. So in the sample, they had a 19, whatever these units are, decrease. And it was anywhere from a 13 to a 25 is what we expect to happen if you get on a vegetarian diet. So that means there is a significant difference in the levels of cholesterol before and after adopting this vegetarian diet. And that's because 0 is not contained in the interval. Okay, remember chapter 9 with all these things? If we decrease the sample size and everything else the same, what's going to happen to the confidence interval? We can talk about it directly from the formula. Decreasing the sample size makes the number we divide by smaller, which means this entire thing will become larger, which means our confidence interval will become wider, which is opposite what I said this morning. So I was wrong this morning. That feels good. Conceptually, if you think about what we're saying is, if we get further away from the size of the population, we need to have a wider net to catch all the possible, to catch the correct value. The closer we get in size of our sample, provided it's randomly drawn, the more precise our sample results are. So the less wide we need it. All right, what if we mess with our standard deviation? So if we increase that, that's a numerator value. So again, what happens if we have a larger standard deviation, that means our standard error piece is going to get bigger, which is a part of the margin of error. This entire piece here is E. So that means we're going to again get a wider confidence interval if we increase the standard deviation. And then finally, if we decrease the confidence level, so we were at 0.9 here and got 1.7. So let's put it to 0.7. Oh, it went from 1.7 to 1.06. If you look at the piece that's affecting, that's this critical T value. If we make that smaller, it means the piece we're adding and subtracting is smaller. In other words, the E will become smaller. So that's going to make our interval narrower. Okay. How are we feeling? Do we feel like you can do a, oh, I didn't notice this before. Do we feel like we can do a hypothesis test? So apparently there's a link here we can click and it will open. Let's see, copy link, paste and go. Well, does it work? Well, no, that didn't work.
Maybe if you were signed in.
Yeah. Maybe. I mean, I'm logged in on this other page. Let's see what happens. I think it just took me a StatCrunch. Hey, there we go. Okay, it worked. So I'll dump it in here, see if it works for you all. If it does, that's nice, because then you don't have to enter the data set. It's got the 2000 to 2014. So before we go anywhere, this is a hypothesis test. How do we know? Because it says right here. Use a hypothesis test of this claim at the 5% level. So the claim is, science researchers state that the average global atmospheric temperature of the Earth is warming. All right, So what I want you to do, take 3 minutes and let's do step 1 together, and then I'll turn you loose. What are the null and alternative hypotheses? So the timer for 3 minutes. Do we know the hypothesis? Or hypotheses, I should say. How about we start with this? Note that when we do one of these dependent samples, where it's matched pairs differences, these are our 3 options. So we can write these 2 ways. We can either show the mean of the difference is equal to 0, or you could do it like the mean of the first is equal to the mean of the second. And the mean of the first is less than the mean of the second. It can go either way. I believe StatCrunch does, subtraction. But either way, in our things here, we just have the mean of the differences. If we use this one, it's going to be equal to 0. Mean of the differences is some sign related to 0. So the question is, which way are we doing the subtraction? We'll look at the table. Which way is it going to go? We always do it vertically, the way we set this up. So I'm going to write it out horizontally because that's kind of how we think about it here. It's always like, why is it that way? So we're going to do the 2000 minus the 2014. Okay. The claim is that the global atmospheric temperature of the Earth is warming. So which of these 2 temperatures do we think is going to be the larger one?
$2014.
Okay, the 2014. So what happens when you subtract a big number from a small number?
We get a positive number.
So what is 5 minus 10?
You get a negative.
You get a negative.
Did I say it wrong? Maybe I said it wrong.
You did. You said it opposite.
I said, what happens when we subtract a big number from a small number?
Yeah.
which is the same thing as saying what happens when we do small minus big. It's awkward. It's weird, right? Okay, so we're going to get a negative number. Now, this morning, I said that this would be greater than 0 and messed up. It was the wrong answer, but it was actually, I wish we would have just left it messed up. I should have just messed up because it was a good learning experience. This is what we expect to happen. So we expect the 2014 numbers, when they're taken away from the 2000 numbers, all to be negative because it's hotter in 2014 than 2000. That's our expectation. So this is the alternative hypothesis, that the mean of all of these differences is going to be negative. How do you feel? Note I scratched off the standard deviation, sample standard deviation. You're going to have to find that on the final exam, but for chapter 3 questions, like if you look at the sample final exam, you do need to know how to do summary stats, which is the way you would find it here. It's this problem. Here it is, standard deviation, right? So you do need to know how to do it, and for this problem, who cares? Let's just do it all in the one spot where it shows up, which is the t-stats matched pairs thing. So let me give you 5 minutes and let's see how far you get. After 5 minutes, I'll check our step 3. Set a timer for 5 minutes. Okay, that was 5 minutes. I'm just gonna quick run the T-stat test, the paired. So we did 2000 as sample 1, 2014 as sample 2. I'm gonna save the differences so I can type them in. We're doing a hypothesis test. We're expecting this to be less than 0. Why not include the p-plot? There it is. Does that look like what you all got? Nice. My assumption is the steps 4, 5, and 6 are relatively straightforward for you. Really, my assumption is that all of this is more or less straightforward for you. Once you've done a bunch of these, it becomes pretty. I feel like it's almost easier than reading the interpretations in some ways. Right, you reject HO on this because 0.0128 is less than 0.05, which is our alpha. And so there is sufficient evidence or enough evidence to support the claim that the average global atmospheric temperature of the Earth from 2000 to 2014 is warming. I don't know that we really can say that our sample should be claimed for all time. It's certainly, our sample is certainly has statistical significance of showing warming from 2000 to 2014. Yikes, we're done. Like, this is the first time ever that we've been done in the first hour of class, first hour and 6 minutes. I wonder what we should do. So I have some options. I would be happy to hang out and answer questions. We could, I could say, here's 5 minutes, do this problem, but that kind of feels like I'm your dad telling you to do your homework. And every 5 minutes I give you a piece of candy if you get work done. But I'm happy to sit here and like answer questions on the chapter 10 project and the chapter 11 project. If anyone has any questions on older worksheets, I know a fair amount of people this morning asked me some questions about 11.1 worksheet 3. I think we did not, we must not have worked through, wait, where is it? This question, no, this question. So some people ask me this one. I don't know if anyone has that one that they want to ask a question about. You could start working. Oh, no, let me say this. We talked a little this morning about how to prepare for the final exam. I had been asked by someone at office hours, like, what's my best advice for prepping for the final exam? And my best advice is, number one, get your reference sheets in order. So find all the ones you use for the midterm and think about how useful they were and whether or not maybe you need to rewrite them. We had a few students this morning talk about having too much on their reference sheets and that was overwhelming, and maybe condensing down to just the core things that you might need. So you have your pre-ones from your midterm. You can rewrite all those or reuse them. You can write, and then plus you can add to that like 3 more for chapter 9 and 10. I think the majority of what you need in terms of reference sheet material is in the appendices. I don't know how much extra you really need to add, but that's something for you to think about. There were a few things like, what's a type 2 error? Beta, right? And how do we know what the type 2 error is? What's the probability of it? A few of those little things. But by and large, the majority of the stuff you need, I think, is on here. So putting that together, and then once you have that together, setting aside 2 or 3 hours of time to sit down and take this sample final exam as an exam. Have just your reference sheet, this exam, your stat crunch and calculator, and your pen you're going to use to take the exam, and just do this. That simulates the exam, and then come to class with this filled out. And if you have questions on it, ask us the questions. And if you just need to know if you got it right, we're going to do that between Cindy and I, and Monday, Tuesday, Wednesday, Thursday of next week. Well, Monday, Tuesday, just Monday and Tuesday. We'll have hopefully taken care of it. You'll have been able to check your answers on all of it. The second thing you can do, if you have more time beyond all that, I recognize that's already a pretty huge time commitment, but if you have more time, there is a huge final exam review set of questions starting on page 399, and this has an answer key at the end of it. You will see that these questions are laid out in the same order as the sample final exam. There's just more of them. Some of the questions in here will look like things we haven't done. I think I remember seeing a few things, like some of the probability stuff is like a little deeper than what we did. So you could skip some of those. Like if you see a question, you have a note, you like, we never did it. Like we did this, we did this. Where's one? Well, maybe we did all these. You know, I'm not seeing any. We didn't really do this. We could kind of ignore that. This is kind of a weird question too. We kind of did it, but it's a weird way. So there's this review has just more questions than you need, and has more than what will be on the actual final exam, but it's a good problem set to work through. Beyond this, you've got your worksheets that you could look over some more, and then after that, you've got Stat Lab that no one probably wants to look at. But those are all your resources for review to start practicing. And we're at that point that it would be good to start working on that. Any questions about that?
So Eric, on the sample final exam, is that going to be similar to the midterm? Will we submit that?
Yes.
Or is it, we are, okay.
And I'm saving these in my back pocket to bump everyone's grades. I know you're still waiting for that midterm bump. It's coming. It's coming.
So when's that sample final exam? Then when is that one due?
So I think we have it set due to be Sunday.
No, it's Tuesday.
Is it Tuesday? Okay. So it's set to be
Tuesday
due
the
on
13th.
Tuesday
Okay.
the 13th.
So I sent you guys an assignment sheet this afternoon.
Why is it so
Eric?
scary?
Why is what scary?
What's
The
scary?
assignment sheet. The
Oh,
assignment
it
sheet.
says, because I said this is the final assignment sheet. Yeah. So you guys, one other thing to note, when I sent that assignment sheet, it did say that the sample finals due on Tuesday, the 13th. And then also all of your My Stat Lab is due on Tuesday, the 13th.
Then everything's done. And Wednesday, you come either to the morning class, and you could come at 8:30 in the morning when I start my tutoring hours, or anytime between 8:30 and 11. I wouldn't come anytime after 11. I would give yourself the full class time to take it. And actually, you know what? On Wednesday, it's a final exam day. I won't be teaching my second class. So I'll probably just turn Zoom on and just be on there all day long. So you can come at 11 and stay till midnight if you want. I mean, I'll probably say, all right, let's put ourselves out of our misery at some point.
So Eric, do you want to not have them be there at 8:30 then?
I'm still gonna.
I wrote that on the thing, but if you don't,
That's fine. I'll have my office out, my tutoring hours, and I'll turn it on. And if someone shows up and says, I want to take the exam, great. I'll toss you in a breakout room and away you go. And really, so that Wednesday, I'll just be here all day long. That seems reasonable. Like I'm just sitting in my basement. No, that's not true. I have to pick up my girl. Do I have to pick them up? No, I don't have them next week. So I'll just be here all day long. It'll just be Zoom turned on. and you all just come in whenever and take it. I think the one thing I would ask out of a bit of courtesy is if you're going to come at nighttime, try to come at the beginning of class at 6. So I won't feel so angry at midnight. Like, you know, like if you come at 8 and want me to stay till midnight, I'm like, oh, but you should have come at 6 is what I'll feel. I won't say it, and I'll smile and I'll let you do it because that's who I am. But
Are you
plus you
gonna
don't want to take it late.
are
Go
you
ahead.
gonna email them the final exam like you did for me midterm?
Yes, I'll do the same thing. What I did for the midterm is I emailed it like when people showed up. So I think I'm gonna stick with that. Just I was talking to some colleagues and they're like, "Don't you send it out early?" And I'm like, "Okay, I won't." So it does just for everyone's. I don't know, just so I can sleep at night. Yeah. And I know I accidentally didn't email it to someone till an hour into the exam last time, and I felt so terrible.
She's not here tonight either.
I know. It doesn't matter. I still feel terrible. So if you haven't gotten it within 2 minutes, like scream at me if you're in a breakout room waiting for the email to come.
I have a question about the final exam. Is it chronological?
Yes.
Thank you.
It's gonna look like, it'll be just like the midterm, where it'll look very similar to this sample final exam, and it will follow the same questions. I think usually the percentage I quote is it's roughly 25% midterm materials, 75% chapters 7 and beyond.
Okay.
There'll be like 2 hypothesis tests, 2 or 3 confidence intervals, and then a bunch of like, hey, is this practically significant? Is this statistically significant? There's always some multiple choice around like which formula should be used to solve this problem. So there's some just blank page, do the whole thing, and then there's a bunch of like, here's one piece of this thing, do you remember how to do it?
Okay.
And this, like what you see here for the sample final exam is going to be very similar to the types of questions you're going to see on the actual final exam. This is like almost always on the final exam. The one that students almost always get wrong is the confidence interval one right here. We used to give this to you where we gave you like the point estimate and a plus or minus value and said, what's the confidence interval? And like no one could remember that it's just plus or minus that point estimate.
Right.
But in this case, we just handed it to you. And this one is the opposite. Like, what's the point estimate? And that problem in the past, people are trying to mash stuff into StatCrunch and there's just not enough information. You just have to remember the connection between the margin of error and the point estimate and how it's put together. So be prepared for ones where you can't use StatCrunch and you just need to understand the connection between everything, and ones where you have to use StatCrunch. And usually the ones where you have to use StatCrunch look like this, right? It's a little bit of data and then a lot of white space for writing. Like here's, this is a hypothesis test, right? It's a whole page of stuff to do. And yeah, so
Patty asked the question in my stat lab, and it was a great question. They ask to use p-value method. So p-value method is just another way of saying do a hypothesis test,
which is the only method we teach. We used to teach what's called a classical method, and it's where you compare the critical value to to the test statistic. So we don't teach that anymore. We just compare p-value and alpha. So that's why it's called the p-value method.
But we never said that. We just said do a hypothesis test. So
never heard that.
I got why you were confused.
I was like, yeah, I'm done.
You're like, what is this? Can I just say, this is my most hated question to grade. This is often the type of question that's on the final exam. Don't think that this is guaranteed to be the one. But too many times students see this one and claim it's independent quantitative, and then the entire test is wrong because you're not doing a matched pairs, which is what this is. And then
Yeah, 'cause
I
they're
have to
related.
decide, what do I do? How do I grade it? Like, this is a 20-point question, right? Do I just take off all 20 points, even though like you correctly follow the method for independent samples, and you clearly know how to do that hypothesis test, but you didn't carefully identify what sample it is. Like, my first years, I just took off all the points. I was a jerk. Now I'm more like, oh, you've got step 2. That's right. You did step 1 roughly correct. Let me find places that I can give you points. So just be really careful with the hypothesis testing, that you know this is single sample and a mean. I've also seen students do a proportion test when it's a mean test, and they get stuck in step 3 because they can't find all the X's, or they can't find the standard deviation, and it's because it's not there. Let's see, Will had a good question. The final exam, I think, tends to be at least 1 page longer. I think the midterm was 9 pages and the final exam tends to be 10 pages. I would imagine however long you took on the midterm, maybe add another 30 minutes, but maybe not, because like, if you're really good at these hypothesis tests, that's a whole page, bam, done. And there's 2 of them. And if you really know, like, if you don't need to take time to construct a confidence interval, or verify the conditions is just C1, C2, C3, C4, like, you might just be able to knock it out. I have had students take the final exam and end it in like an hour and a half or 2 hours, and do really well on it. And then there's some students that do it in 30 minutes and like put their name on it, but they never came to class or did any of the worksheets. So I respect them for coming to look at the exam.
Now, when we have
Go ahead.
final grades for the courses,
So that's a really good question, Sarah. Here's the fun news. I have a strict deadline that I must meet or I get in trouble. I must have the grades done within 48 hours after the end of the semester, 48 business hours. So the semester ends on the 16th, I believe. So I must have them in the computer by December 20th at midnight. So they have to be done by then. I know that whatever I say, you can't believe, because I have not, that's what I've proven is truth. My hope would be that the final exams are done here. I'd have them graded on the 15th or 16th in between these 2 days, hopefully the 15th. And that I would say, grades are in the computer, please look for mistakes. And then that would give you all a chance to look for anything I screwed up, and then I could fix it before actual things are posted. And I probably wouldn't put them in the official grading area until the 20th, just to give people time to check it out. I'm going to pause the recording for just a second.
Helps me is when
This meeting is being recorded.
when it said in that about just the University of Waterloo, and then it says on the same date in the year 2000, and then again in 2014, makes me think before and after, like Cindy was telling us, which automatically takes me to dependent.
it might have been helpful if I read it.
I do the same thing.
I did it too, right? I just dived in.
I
I'm like,
just started doing it. I didn't read it.
Oh no, I think it was like last week. I'm like, where are you guys getting the confidence level? I don't know where it is. And then I finally saw it was in the table.
Yeah.
That would be my other advice. Like, on your reference sheet, maybe you should just make one reference sheet and just one page and write in real big letters, read the problem. Read it.
Read
And
it.
that, like,
all
it
of it.
solves half, it's like half the battle. Because you are going to get excited. You could be like, yes, I know how to do this. I'm just going to go. And then you might miss one little piece and I don't know. I will also be giving this exam on Thursday on campus, pen and paper, and JM 248 if you want to come in person. When am I giving it? 11 to 1 and probably earlier. So if you want to come take it on Thursday and have a print copy handed to you, maybe send me an email to let me know you're doing that, and feel free to drive to campus and do that, Central Campus. That is an option. I'm a little scared to offer that if like you plan on doing that and then don't do it. And then I'd have a 0 for a mid-final exam for you. I hate being in that position. So,
But in reality,
if that,
that's all on us.
it does, but it always hurts me a little because I'm like, oh, what could I have done to make sure it hurts me. I don't want to give anyone a 0. So that's an option. Just let me know. I'd be happy to accommodate that. And you can ask me questions in person if you want. My in-person people ask me tons. And I try really hard to keep my mouth shut, but I answer them a lot. You can also ask questions in the Zoom breakout thing. We should probably practice it. There is a way to raise your hand so I can see you and come into the room where you're at and talk to you. I will try to jump around like I did during the midterm and just check in on you. That's always a little awkward because you're working away and I'm like, hey, how's it going? And you're like, whoa, look at that crazy man. But I will try to do that to see if you have questions, but also feel comfortable asking. And feel comfortable going to the bathroom if you need to. You don't have to tell me, just go to the bathroom and come back if that happens. I've heard stories of like students having exams proctored and they're sick and they're asking the proctor, can I throw up? And they're like, yes. And then they puke and then they keep going. Those are like extreme cases where it's a third-party company that's like literally watching you every second of the exam. I think this thing made it to the Supreme Court, actually.
Wow.
And it's like they determined it was not legal to require a student to show a professor their area. So.
I just have one question and then I'm going to scoot. So then next Monday and Tuesday, we'll be going over probably the sample final exam together, asking questions and stuff like that before we take the test.
That's the plan.
Okay, cool. All right, I'm going to scoot. See you guys.
See ya.
Bye.
Hi, Patty.
Night, Will. Night, Hope.
Oh, good night, everyone. Rest well.
All right, I think I'm good.